Welcome to Intro to Power Series. So quick definition. If we have a series, if we have a sequence, A sub n, then the corresponding power series in X is the series, the sum from n equals 0 to infinity of A sub n times x to the n. Furthermore, if we have a constant c, then the power series in X centered at C or around C is, we take the sum from n equals 0 to infinity of A sub n times in parentheses x minus c and the parentheses n raised to the n. So this is what is called a power series. Some quick examples of some basic power series. The sum from n equals 0 to infinity of x to the n over n factorial is a power series. Right. It is essentially, for n equals 0, we would have x to the 0th, we just deem to be 1. And then plus x to the first power over 1 factorial is just x. Then we would have plus x squared over 2. Plus x cubed over 3 factorial would be over 6. Plus x fourth, or x to the 4th over 4 factorial would be 24. And we keep going. So this is one example of a power series in X. Another example, we could take the sum from n equals 0 to infinity of n times x to the n. This again is a power series in X. You can kind of think of them as infinite polynomials, right? It looks like a polynomial, but it has no highest degree term. It goes on forever. So in this case, oops, sorry for the scrolling. N equals 0 would just be a 0 term, right? So that first term would just be 0. Then when n equals 1, we would have 1 times x to the first power. Then we have 2 times x squared plus 3 times x cubed plus 4 times x to the 4th, etc. So again, power series are essentially infinite polynomials. So power series in X are essentially infinite polynomials. we can evaluate the power series at any particular value of x by plugging it in and then using our convergence theory and tricks from previous sections, right? And then one more, let's do a power series in x centered at something else. So let's do the sum from n equals 0 to infinity of 2 raised to the nth power times x minus 3 raised to the nth power. This is a power series in x centered at 3. Right. If we wrote this out, 2 to the 0th is just 1. So we have x minus 3 raised to the 0th power, again, is just 1. So we'd have 1 plus 2 to the first power is 2, then times x minus 3 to the first power. Then 2 to the second power would be 4 times x minus 3 squared. Then 2 to the third power would be 8 times x minus 3 cubed. And then we continue on. So now this is just essentially an infinite polynomial that has been translated, right? So this is an infinite polynomial that has been translated to the right by 3. And so again, note we can evaluate the polynomial at any, we can evaluate, sorry, the power series, I shouldn't say polynomial. We can evaluate the power series at any x equaling, I don't know what we should call it, at any x equaling, let's go with b, where, or for which, the sum from n equals 0 to infinity of a sub n times b to the n converges. Right? That would essentially be what we consider to be the value of the polynomial at x equals b, or of this power series at x equals b would be the value that we get when we plug in b for x, and then that's just a series of constants. Right? The terms are constants, no longer involving x, so we can evaluate whether it converges or diverges. So in the next video, we will go ahead and take a look at sort of how we figure out where our power series converges or diverges.